Hello everyone, it's Calvin Miner. In this video, we are going to evaluate limit using the gradient of tangent line. Let's begin with a review of how we find the gradient of a tangent line. We know that the gradient can be obtained from two different formulas. From these two formulas, we can build an equation that relates them together. Since the derivative can be defined using a limit, we can write the derivative at a point using the notation d over dx at x equals k, which is the same as f prime of k. Also, from the property of limits, the limit of f of x divided by g of x can be written as the limit of f of x divided by the limit of g of x, as long as both limits exist. Using this property, we can rewrite the equation from the two formulas into a new form. And because the limit of a sum can be written as the sum of limits, we can transform the equation again. Since the limit of f of x is the same as substituting directly into the function f of x, we can rewrite the equation in that way. Next, we move the term limit of x minus k to the left-hand side and use the property of limits to rewrite the equation in a clearer form. Then, the negative of the limit of f of k, which is on the right-hand side, can be moved to the left-hand side. Again, because the limit of a sum can be written as the sum of limits, we can rewrite the equation into a simpler form. This final equation is the key formula that we will later use to solve limits when we encounter indeterminate forms. Now, let's consider a specific case. If the value of f of x and g of x at x equals k are both 0, then the limit of f of x divided by g of x as x approaches k becomes 0 over 0. And this is an indeterminate form. But we can use the equation that we just derived earlier to handle this situation. Since the limit of f of x divided by g of x can be written in that equation, we can carefully pull the limit operation outside and rewrite it. And because f of x and g of x are both 0 at x equal k, we can substitute those values into the equation. In both numerator and denominator, we have a factor of x minus k, so we can simplify by canceling it. Finally, we arrive at the result. The limit of f of x divided by g of x as x approaches k is equal to the limit of f prime of x divided by g prime of x as x approaches k. However, it is very important to remember this method is only valid if f of k equals 0 and g of k also equals 0. Okay, now let's look at another situation. Suppose the limit of f of x and the limit of g of x as x approaches k are both infinity. In this case, the limit of f of x divided by g of x as x approaches k is infinity divided by infinity, which is also an indeterminate form. But since the limit of 1 over x as x approaches infinity is 0, we can cleverly rewrite the expression. The limit of f of x divided by g of x as x approaches k can be turned into the limit of 1 divided by g of x divided by 1 divided by f of x. This gives us a new fraction in the form 0 over 0. Let's define m of x as 1 divided by g of x and n of x as 1 divided by f of x. As x approaches k, both m of x and n of x approaches 0. This means the limit of f of x divided by g of x is equivalent to the limit of m of x divided by n of x, which is 0 over 0. From here, We can now use the same principle we found earlier. The limit of f of x divided by g of x equals the limit of m prime of x divided by n prime of x. Now, let's continue with the simplification. We differentiate m of x and n of x using the chain rule. Then we substitute these derivatives back into the equation. So we can rewrite the expression in terms of f of x and g of x again. After substitution, we simplify the equation to reduce it into a clearer form. To make it even more precise, we applied three important properties of limits step by step to rewrite the expression. Once simplified again, the expression becomes much clearer. By rearranging terms and simplifying, we finally conclude that the limit of f of x divided by g of x as x approaches k is equal to limit of f prime of x divided by g prime of x as x approaches k. In the case when f of x and g of x both approach infinity. And with that, we can now understand why L'Hopital rule works. It says that the limit of f of x divided by g of x as x approaches k is equal to the limit of f prime of x divided by g prime of x as x approaches k. If and only if both f of x and g of x approaches 0, or both f of x and g of x approaches infinity as x approaches k. I hope this video will help you in your learning journey. Until next time, happy learning.